Hello, class. So today I'm going over the study guide, which y'all should have tried to do at home. Um, so the study guide goes over a little bit of everything that we did. So of course that means I'm going to go over it again. But if you want the thorough breakdown, either go watch the video that accords to that lesson. I'm also thinking about making a video that talks about specific stuff that I feel like we might be getting confused about, but I'm gonna see how much time I have for that. Okay, so looking at number one says which number line shows the approximate location of the square root of 18. So the key word here we need to pay attention to is approximate, right? Because when we approximate something, we should immediately think about estimating and or rounding. All right, so there's a certain way we work when we're approximating square roots. Honestly, there's a certain type of square roots that we approximate. So let's go to the very beginning. The only time you would be approximating a square root is when the number that's underneath the square root bracket is not a perfect square. I'm gonna say that again. The only time that you have to do this approximation thing is number one, if the question asks you to do it, and or if that number that is underneath this square root bracket is not a perfect square. Because for example, if it was a perfect square, right, so say this was 16, I know that the square root of 16 is 4, because if I square 4 I get 16. All right, very simple process to understand. All right, so now let's break down how we get this approximation. So when we approximate square roots, what we do is we see what perfect squares the square root we are trying to approximate sits in between. Okay, so that means we see what comes before and we see what comes after. All right, so since this is the square root of 18, right, we know that the square root of 16 comes before it, and then the square root of 25 would come after it. All right, which means if we're breaking it down, like I just said, the square root of 16 is 4 or equal to 4, and the square root of 25 is 5 or equal to 5, which means that if I'm using a number line, or if I'm trying to find what number I would start off with for approximating the square root of 18, I know that it falls between 4 and 5. Okay, so since it falls between 4 and 5, I know that it's in the middle. So that means the first number that I would use, or the whole number to this square root, would be 4. It's 4 point something. Okay, all right. Everybody got that? Okay, so now just with that information, I can actually eliminate some options. So A could be eliminated because A has the point on exactly 4. If the answer was exactly 4, they would be asking me for the square root of 16, not the square root of 18. So I can eliminate A. I can eliminate B because B is in between 3 and 4 and not 4 and 5. So I can eliminate that. So then actually I can also eliminate D because D is on 9, which the only way you would get 9 as an answer if you was doing the square root of 81, because the square root of 81 is equal to 9. So that really, without doing any work, just finding the first number, right, I know that my answer choice should be C for this one. Okay, but now just for the sake of learning how to do this, I'm going to finish working the problem out, okay, and like help you realize why the point is where it is in between 4 and 5. Okay, so as we established earlier, the square root of 18 falls in between the square root of 16 and the square root of 25, which means it also falls between 4 and 5. Okay, now, in order to know what number it would be closer to, it's a very simple thing. You see what number 18 is closer to. Is 18 closer to 16, or is 18 closer to 25? Obviously, 18 is closer to 16, which means that 18 should be closer to 4. All right, which is why in the answer choice, which is correct, which is C, you see that the dot is very close to 4. Okay. Of course, there's more to the process to get the actual decimal numbers, but I'm not going to do that. I'm going to leave that in the lesson video, and I'm going to leave that in the video that I might make, okay? But just understand that's how you find where non-perfect squares that are being square rooted fall in the placement of like numbers, okay? So now let's move on to number 2. So looking at number 2, it says find the exact length of the hypotenuse C. So the couple of things here should let us know what we're doing. It says hypotenuse, which should cue us to a certain equation or a certain theorem. We're looking for C. All right, we're using a right triangle. All these things should tell us that we're using the Pythagorean theorem. And when we use the Pythagorean theorem, we first need to know the equation, which the equation is a squared plus b squared equals c squared. Remember that a and b are your legs, which is the shortest side. C is always the longest side, which is usually opposite of the right angle, while your legs are adjacent to the right angle, which just means next to. All right, those are the things that we went over while I was still here. Okay, remember, it doesn't matter what you plug in for A and B as long as they are your legs. So we can plug in 12 for A, which means that's 12 squared, and we can plug in 5 for B, which means that's 5 squared equals C squared. 12 squared is 144. 5 squared is 25 equals C squared. We know that 144 plus 25 equals, okay, that's 961. So that would be 169. Let me make that look a little better. Equals C squared. Okay, so now remember, when we get to this part, we do not have our final answer. We still have one step left. We have to square root C squared in order to get that squaring off of it, which means we also have to square root the number 169. So on the side with C, these end up canceling out because a square root sign breaks down something being squared, whether it's a number that's already been squared or if it's something trying to square. All right, so that means C equals, what do you square to get 169? The answer should be 13. All right, that one's pretty simple, pretty easy. I'm pretty sure y'all have y'all little cheat sheet papers. Since I most likely won't be here for the test, I mean, I guess it's allowed for you to use that paper. I don't mind. You know, whatever helps, because you still gotta know how to use it. Just like I've said before, I can give you all the cheat sheets in the world. If you don't know how to use it, it's a waste of time. All right, so continuing on and forward. Number 3 says match each root to its equivalent value. Write one value from the given answer choices in each box. So we have answer choices at the bottom. They've already did the hard part for us. So there's a couple of ways you can kind of go about this depending on how your mind thinks. So when you look at the root, okay, right? So the first one says, what is the square root of 1600ths? Or you can say 0.6. So remember the way I told y'all to do this, you know, you would pretend like the decimal's not there. If I pretend like the decimal's not there, that would end up me looking at the number 16, okay? So I'm pretty sure some people are confused. They're like, oh, there's a 0 in the front. That 0 wouldn't do nothing if the decimal was gone. It would still just be the number 16, okay? So I'm squaring this, so that means I know that I need to use only something twice, right? So the only thing that I can use twice to get 16 would be 4, okay? But if I do 4 times 4, that's going to be 16. This is a decimal answer, so, and it has 2 decimal places, right? So since I know squaring something does multiplication, my answer should be 0.4, which has 1 decimal place, but I need 2 of them, so that's going to give me my 2 decimal places for my answer. So the first answer choice would be 0.4, okay? All right, so looking at the next one, we have the cubed root of 8. Remember the difference between the signs. The square root sign is just a regular sign. The cube root sign has a little 3 on it. So the cube root of 8, with what number can you multiply times itself 3 times to get 8? Using your paper, you should see that that number is 2. Also, just as a reference to something, they're not asking for all possible solutions, because we know that we could have also made this number negative, and no, we actually can't make that one negative because it's cubed, but we could have made the first number negative and still gotten the same answer. Just a reference. Don't overthink it. I was just trying to give you information that we should already know. Okay. All right, so obviously doing number 3, the square root of 16, you should have gotten 4, because 4 times 4 equals 16. All right, and then for the last one, we have the cubed root, or what is the cubed root of 27 over 64. Remember, I told you guys, when you're trying to square or cube fractions, you can take the numerator by itself and take the denominator by itself and figure out if those numbers by themselves have a cubed or square root. So if I look at 27, I know that the cubed root of 27 is 3. And if I look at 64, I know the cubed root of 64 is 4. So that means 3/4 would be the answer for the last one, okay? This should have been pretty simple. That's literally just breaking down square roots, and y'all have a paper to do that, so it should be clicking by now. All right, so number 4 is kind of similar to number 3. Okay, it says solve the equation. Okay, so we got x to the 3rd power is equal to 0.064, or 64 thousandths. Okay, so remember, when we're solving an equation, right, in order to get to solve the equation, we have to get x where it is just x and there's nothing else happening to it. Okay, so in order to get x by itself, or as just x, we need to eliminate or get rid of the cubed root sign. So in order to get rid of the, not cube root sign, the cubed sign. In order to get rid of the cube sign, you need to cube root it. All right. Whatever you've done to one side of the equation, you have to do to the other. Remember, because it is a balancing act. It cancels the cubing and the cube root over here, which leaves you with x. And then on the other side, once again, we have a decimal, but if we pretend like the decimal's not there, we're looking at the number 64. Is there a number that we can cube to get 64? We actually just did that in number 3. That number would be 4, but we can't use 4 because 4 is going to give us a whole number of 64. Since this is a decimal, your answer should be 0.4. Okay, because we know if we cube this, that'll give us 3 decimal places while we are multiplying. All right, all the things that we have learned should be connecting and adding together, even stuff that we learned way in the beginning of the year, like with multiplying decimals and fractions and stuff like that. All right, so number 5 is actually a lot easier than it looks. If you remember the little hints or the things I pointed out in the lesson yesterday. So the first one said, well, let me read the instructions first. It says indicate whether each number is rational or irrational. So technically, if you can look at it and know if it's rational or irrational, you don't have to do any work. But if you can't just look at it and figure it out, then you might have to do a little work. So I know just by looking at these, for at least one of them, we're going to have to work it out so we can see for a fact that it is rational or irrational. All right. So if we look at the first one is the square root of 0.09, or 9 hundredths. So once again, it's a decimal, so if I pretend like the decimal's not there, that would give me the number 9. Does 9 have, when 9 is square rooted, does it have something that it goes into? The answer is yes. It would be 3. So the answer, if I was solving what is the square root of 0.09, would be 0.3. The question now is that a rational number? Yes, it is, because remember, all terminating and repeating decimals are rational numbers. A terminating decimal just means that the decimal stops or it ends. 0.3 is a decimal that ends because it does not have a repeat bar that says it keeps going, and it doesn't have these little dots that say it keeps going. Okay, so this one would be rational because it is a terminating decimal. All right. So then the next one, it says negative square root of 11. Remember when I talked about making a square root negative, it's just like making a number negative. You just put a negative sign in front of it, okay? Because something being square rooted has a number value that comes out of it, so that's just making the number value negative. All right, it's not nothing extra complicated about it. Now, the thing that makes this easy is because, just like I said earlier when we were looking at I think it was number 1, when you have a number under the square root sign that is not a perfect square, you cannot get a whole number answer out of it. Okay, so since you cannot get a whole number answer out of it, there is a method you can go through, which we did in number 1, to try to figure out where it would be at, like what the whole number would be. And then after that, if we continue, we would be figuring out the decimals, but that process never stops. Okay, and also we would never know what the next number is. We would have to keep experimenting like I did in yesterday's lesson video to figure it out. So since it is a number or a decimal number that never ends, that would qualify it as irrational. Okay, so, and also going along with this, I remember the quick hint that I told you, which is that any number being square rooted that is not a perfect square will automatically be irrational, because even though we can approximate what the number is as a mixed number, because it's going to have a whole and it's going to have pieces, it still would never stop. Like, we would never get a solid answer. Okay, and yes, irrational numbers can be negative, because remember the chart that I made the little circles on my notepad shows what is classified as a rational number, and negatives do fall in there because negative numbers are integers. Integers are rational numbers. Okay, all right, so we look at the next one. The next one is 0.3033033 dot 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 dot. So looking at this number, there is not any pattern that indicates that I would possibly know what the next number is. Like, because I mean, the first thing was like a 3 then a 0. Then there was another 3. So if I was assuming a pattern was happening, I would assume that a 0 would be coming next, but it was another 3. Okay, so there's clearly no pattern here. There's no repeat bar to indicate that a pattern is going to start. So this number is going to keep going, and I honestly couldn't tell you if a 0 or a 3 is going to come next. Once again, falling in the same category as this one, where the number keeps going and we can't predict what's coming next, so that would be irrational. Remember, a number continuing isn't necessarily what makes it irrational, because, you know, repeating decimals keep going, but they are rational because we know what's coming next. Like, we could predict what the next number is, which means we understand it, because, you know, I could tell you, oh yeah, 3's coming next. With things like this, and if we actually try to solve that one, we don't know what's coming next. It's not predictable, so that's irrational. Okay, and then for the last one is the fraction -7/9. So it being set up as a fraction already could kind of make us think that it's a rational number, because remember, the definition of rational numbers is numbers that can be represented as fractions. But remember, I told you to check the fraction to see if it's rational or not. Means you have to turn it into a decimal and see if that decimal repeats or terminates. All right, so in order to turn a fraction into a decimal, you have to divide the two numbers. You always divide the numerator by the denominator. So if we're dividing 7 by 9, you don't have enough, so that's 0. Got to add a decimal, move the decimal up, and then you have another 0, so then that would be 70. Okay, you should be able to get 9 7 times out of 70, which would turn into 63. 70 minus 63 is 7 again, which means we would continue going, and now we have the number 70 again. So we can actually stop right here, because we can see that in our working the problem out, we would get 70. We've gotten 70 twice, and if it works the same way it worked the first time, where we can only get 7 9s out of 70, which means it's going to be subtracted 63, and then we get 7 again. We know that this 7 is what's repeating. So the answer, if we were turning it into a decimal, would be it's a negative 0.7 repeating, but it's a repeating decimal, which falls into the category of a rational number, which means this one would be rational. Okay, so that's rational, irrational, irrational, and rational as those answers. All right, so then finally for number 6. Number 6 is not that tough. Number 6 says, consider the equation x squared equals 4 over 49. Which statement is correct? So if we look at the first statement, it says this equation has no solutions. Well, we should know that that's not true, because if we sit here and try to solve this equation, right, because that's how we would find the solutions, first we have to get rid of the squaring of x, which means we put under the square root sign. What you do to one side, you have to do to the other. So that would be x equals, remember I told y'all when we square root fractions, we take them one piece at a time. The square root of 4 is 2, and the square root of 49 is 7. Okay, so it definitely has a solution, so that means A would not be an option. Okay, so now letter B says the only option is 2 over 7. So remember, I kind of mentioned this in the beginning, because if we think back to lesson 18, I like to reference that lesson because y'all were doing pretty good with that lesson. Yes, the positive version of this number is an option, but we could also have this negative and get the same answer, because a negative times a negative is a positive. So if you did this squared, you would still get this as an answer choice. Okay. All right, so now we know that B is not an option. We also can eliminate C too, because C is just saying that the negative version is the only option, which would leave you with D, which is obviously the correct choice, where you should have an answer choice of either positive 2 out of 7 or negative 2 out of 7. Okay, so personally, I think you guys should be able to get this really easily. Please make sure that you watch this video as many times as you need to. Go back and watch the video on the lessons with the concepts that you don't get as many times as you need to. Like I said, I'm contemplating whether I'm gonna make a little short brief video that just talks about like the skills and why we do certain things to get them. It's gonna more so deal with what I did in number 1 with trying to find the spot, because I feel like that's confusing people. I also talk about like what makes something rational or irrational, because that was today's lesson, and I got a couple of emails saying that people were confused about that. So if I do make a little short video, it's going to be labeled quick tips for topic D test. So, watch that if you feel like you need to watch it. But other than that, study, be prepared for Friday, and have a great day.